start by understanding what thermal expansion actually means. In physics, thermal expansion refers to the tendency of matter to change its shape, area, and volume in response to a change in temperature. When a material is heated, its particles begin to move more rapidly, causing the material to expand. This phenomenon is observed in solids, liquids, and gases, though the effect is most noticeable in gases. Thermal expansion is a fundamental concept that helps explain many everyday occurrences, from why bridges have expansion joints to why a metal lid loosens when run under hot water. Throughout this video, we'll explore the science behind this process and see real-world examples. Understand thermal expansion, we need to look at the behavior of particles. All matter is made up of tiny particles that are constantly in motion. When heat is applied, these particles gain energy and vibrate more vigorously. This increased movement pushes the particles further apart, causing the material to expand. The amount of expansion depends on the material and the temperature change. This principle is crucial in physics and engineering as it affects how materials are used in construction and manufacturing. By grasping this concept, we can better predict and control the effects of temperature changes on different substances. Solids are particularly interesting when it comes to thermal expansion. Although the particles in solids are closely packed, they still vibrate when heated. As the temperature rises, these vibrations increase, causing the solid to expand slightly. This is why metal rails on train tracks have small gaps between them. These gaps allow for expansion during hot weather. Without these gaps, the rails could buckle and cause accidents. The expansion in solids is generally less than in liquids or gases, but it's still significant enough to require careful consideration in engineering and design. Liquids also expand when heated, but the effect is more pronounced than in solids. The particles in a liquid are less tightly bound, so they can move past each other more easily. When heat is added, these particles move faster and spread out, causing the liquid to expand. This is why a thermometer works. The liquid inside expands as it gets warmer, rising up the tube to indicate the temperature. Understanding how liquids expand is important in various industries, from designing pipelines to creating accurate measuring instruments. Gases show the most dramatic thermal expansion. The particles in a gas are far apart and move freely. When heated, they gain even more energy and spread out rapidly, causing the gas to expand significantly. This is why hot air balloons rise. The air inside the balloon is heated, expands, and becomes less dense than the cooler air outside. The expansion of gases is a key principle in many technologies, including engines and refrigeration systems. By understanding how gases respond to heat, we can harness their properties for a wide range of applications. Linear expansion refers to the increase in length of a material as it is heated. This type of expansion is most commonly observed in rods, wires, and beams. The amount of linear expansion depends on the original length, the temperature change, and the material's properties. For example, a metal rod will become slightly longer when heated. This concept is crucial in construction, where materials must be able to accommodate changes in length without causing structural problems. Engineers use formulas to calculate how much a material will expand, ensuring safety and stability. Thermal expansion doesn't just affect length, it also impacts area and volume. When a material is heated, its surface area and overall volume can increase. This is especially important in containers and tanks, where even a small change in volume can have significant effects. For example, a metal tank storing fuel will expand as the temperature rises, potentially leading to leaks if not properly designed. Understanding area and volume expansion helps engineers create safer and more efficient storage solutions. Every material has a unique coefficient of thermal expansion, which measures how much it expands per degree of temperature change. This coefficient is a critical property in materials science and engineering. Materials with a high coefficient expand more with heat, while those with a low coefficient expand less. For example, aluminum has a higher coefficient than steel, so it expands more when heated. Knowing the coefficient helps engineers choose the right materials for specific applications, ensuring that structures remain safe and functional under varying temperatures. Bridges are a classic example of how thermal expansion is managed in engineering. As temperatures rise and fall, the materials in a bridge expand and contract. To prevent damage, engineers include expansion joints, gaps that allow the bridge to move slightly without cracking or buckling. Without these joints, the stress from expansion could cause serious structural problems. This practical application of thermal expansion keeps bridges safe and functional year-round, regardless of weather condition. Railway tracks are another area where thermal expansion must be considered. Metal rails expand in hot weather and contract in the cold. To accommodate this, small gaps are left between sections of track. These gaps prevent the rails from buckling, which could lead to derailments. Engineers carefully calculate the size of these gaps based on the expected temperature range. This attention to detail ensures that trains can run safely and smoothly, no matter the season. Thermometers rely on thermal expansion to measure temperature. Inside a traditional thermometer, a liquid such as mercury or alcohol expands as it gets warmer, rising up a narrow tube. The height of the liquid corresponds to the temperature. This simple yet effective design has been used for centuries. Understanding how thermal expansion works allows us to create accurate and reliable measuring instruments for a wide range of applications, from weather forecasting to medical diagnostics. Hot air balloons are a fun and practical example of thermal expansion in action. When the air inside the balloon is heated, it expands and becomes less dense than the cooler air outside. This difference in density causes the balloon to rise. By controlling the temperature of the air, pilots can make the balloon ascend or descend. This principle is a direct application of the way gases expand when heated, demonstrating the power of thermal expansion in a visually striking way. Glass is particularly sensitive to rapid temperature changes. When a hot liquid is poured into a cold glass, the inner surface expands quickly while the outer surface remains cool. This uneven expansion can cause the glass to crack or shatter. To prevent this, glassware is often designed to withstand thermal shock, or users are advised to warm the glass gradually. This example highlights the importance of understanding thermal expansion in everyday material. Thermal expansion isn't just a scientific concept, it affects our daily lives in many ways. For example, metal lids on jars can be loosened by running them under hot water, which causes the metal to expand slightly. Similarly, doors and windows may stick in hot weather as the wood expands. By recognizing these effects, we can better understand and manage the materials around us, making life a little easier and safer. In construction, thermal expansion is a key consideration. Buildings, bridges, and pipelines must all be designed to accommodate changes in temperature. Expansion joints, flexible materials, and careful planning help prevent damage caused by expansion and contraction. By understanding how materials respond to heat, engineers can create structures that are both safe and durable, even in extreme climates. Pipelines that carry hot liquids or gases must be designed to handle thermal expansion. As the temperature of the contents rises, the pipeline itself expands. Engineers use expansion loops or bends to absorb this movement, preventing leaks or ruptures. This careful design ensures that pipelines remain safe and functional even as temperatures fluctuate. Electronics are also affected by thermal expansion. As devices heat up during use, their components expand. If not properly managed, this expansion can cause connections to loosen or break, leading to malfunctions. Engineers design electronic devices with materials that can withstand these changes, ensuring reliability and longevity. Proper cooling systems also help control temperature and minimize expansion. Cooking provides many examples of thermal expansion. When you heat a pan, it expands slightly. Similarly, dough rises as it bakes because the gases inside expand with heat. Understanding thermal expansion helps cooks achieve better results, from baking bread to making candy. It's a reminder that physics is at work in the kitchen every day. Automobiles are designed with thermal expansion in mind. Engine parts, exhaust systems, and even tires expand as they heat up during operation. Manufacturers use materials that can handle these changes without warping or failing. Regular maintenance ensures that expansion doesn't lead to mechanical problems, keeping vehicles safe and efficient on the road. Aerospace engineers must account for thermal expansion when designing aircraft and spacecraft. As these vehicles move through different environments, their materials experience extreme temperature changes. Expansion and contraction can affect performance and safety, so engineers use specialized materials and designs to manage these effects. This careful planning ensures that aerospace vehicles remain reliable in the harshest conditions. Clocks and watches must be designed to minimize the effects of thermal expansion. Even small changes in the size of gears or springs can affect accuracy. High-quality timepieces use materials with low coefficients of expansion, ensuring that they keep accurate time regardless of temperature changes. This attention to detail is a testament to the precision of modern engineering. Artists and conservators must consider thermal expansion when working with materials like metal, wood, and glass. Changes in temperature can cause sculptures or paintings to warp or crack. By understanding how different materials respond to heat, artists can create works that stand the test of time, and conservators can protect valuable pieces from damage. Thermal expansion isn't limited to human-made objects, it also occurs in nature. Rocks and soil expand and contract with temperature changes, contributing to the formation of cracks and the weathering of landscapes. This natural process shapes the environment over time, demonstrating the power of thermal expansion on a grand scale. Water pipes can burst in winter when the water inside freezes and expands. This is a form of thermal expansion, where the change in temperature causes the water to increase in volume. To prevent this, pipes are insulated or made from materials that can withstand expansion. This example shows how understanding thermal expansion can help prevent costly and inconvenient damage. Sports equipment is also affected by thermal expansion. For example, the pressure inside a basketball or football can increase on a hot day as the air expands. Manufacturers design equipment to handle these changes, ensuring safety and performance. Athletes and coaches also take temperature into account when preparing for games, adjusting equipment as needed. Musical instruments, especially those made of wood or metal, can be affected by thermal expansion. Changes in temperature can alter the pitch or cause parts to warp. Musicians often tune their instruments before performances to account for these changes. Instrument makers use materials and designs that minimize the effects of expansion, ensuring consistent sound quality. Jewelry made from metals can expand or contract with temperature changes. Rings may feel tighter in the summer and looser in the winter. Jewelers take this into account when sizing pieces, ensuring a comfortable fit year-round. This is another example of how thermal expansion affects everyday objects in subtle but important ways. Medical devices and implants must be designed to handle thermal expansion. As the body's temperature changes, materials inside the body can expand or contract. Engineers use biocompatible materials with low coefficients of expansion to ensure safety and effectiveness. This careful design helps improve patient outcomes and reduces the risk of complications. Packaging materials must also account for thermal expansion. Containers that hold liquids or gases can expand or contract with temperature changes, affecting their integrity. Manufacturers use materials that can withstand these changes, ensuring that products remain safe and undamaged during shipping and storage. Power plants and energy systems must manage thermal expansion in their equipment. Boilers, turbines, and pipes all experience temperature changes during operation. Engineers design these systems to accommodate expansion, preventing leaks and maintaining efficiency. This careful planning is essential for reliable and safe energy production. Food packaging must withstand changes in temperature during storage and transport. Cans, bottles, and cartons can expand or contract, affecting their seals and contents. Manufacturers use materials and designs that accommodate these changes, ensuring that food stays fresh and safe to eat. Scientists must account for thermal expansion when conducting experiments. Precision instruments and measurements can be affected by even small changes in temperature. By controlling the environment and using materials with low coefficients of expansion, researchers ensure accurate and reliable results. Manufacturing processes often involve heating and cooling materials. As parts expand and contract, they must be carefully measured and assembled to ensure a proper fit. Understanding thermal expansion helps manufacturers produce high-quality products that perform reliably under different conditions. Plumbers must consider thermal expansion when installing pipes and fixtures. Hot water causes pipes to expand, which can lead to leaks or bursts if not properly managed. Expansion tanks and flexible joints help absorb this movement, protecting plumbing systems from damage. Heating, ventilation, and air conditioning (HVAC) systems must be designed to handle thermal expansion. Ducts and pipes expand and contract as temperatures change, which can affect performance. Engineers use flexible materials and joints to accommodate these movements, ensuring efficient and reliable operation. Roads and highways can crack or buckle due to thermal expansion. Asphalt and concrete expand in hot weather, creating stress that can damage the surface. Engineers use expansion joints and special materials to manage these effects, keeping roads safe and smooth for drivers. Ships and boats experience thermal expansion as they move between different climates. Metal hulls and components expand and contract, which can affect performance and safety. Shipbuilders use flexible designs and materials to accommodate these changes, ensuring that vessels remain seaworthy in all conditions. Railway engineers must constantly monitor and maintain tracks to account for thermal expansion. Special tools and sensors are used to measure rail temperature and expansion, allowing for timely adjustments. This proactive approach helps prevent accidents and ensures the smooth operation of trains. Power lines expand and sag in hot weather as the metal wires heat up. Engineers design power lines with enough slack to accommodate this expansion, preventing breakage and maintaining a reliable power supply. This is another example of how thermal expansion must be considered in infrastructure design. Glass windows can crack if they expand too much in the heat. Window frames are designed to allow for this expansion, preventing stress and damage. By choosing the right materials and designs, manufacturers ensure that windows remain safe and functional in all weather conditions. Precision scientific instruments must be designed to minimize the effects of thermal expansion. Even tiny changes in size can affect measurements and results. By using materials with low coefficients of expansion and controlling the environment, scientists ensure the accuracy and reliability of their experiments. Watchmakers use materials with low coefficients of expansion to ensure that watches keep accurate time. Temperature changes can cause gears and springs to expand or contract, affecting performance. By carefully selecting materials and designs, watchmakers create timepieces that remain reliable in any climate. Optical devices like cameras and telescopes must account for thermal expansion. Lenses and mirrors can change shape with temperature, affecting focus and clarity. Engineers use special materials and designs to minimize these effects, ensuring sharp images and accurate observations. Spacecraft experience extreme temperature changes as they move in and out of sunlight. Materials expand and contract rapidly, which can affect performance and safety. Engineers use advanced materials and flexible designs to manage these changes, ensuring that spacecraft remain operational in the harsh environment of space. Thermal expansion is a fundamental concept in physics that affects nearly every aspect of our lives. From bridges and buildings to everyday objects and natural landscapes, understanding how materials respond to temperature changes helps us design safer, more reliable, and more efficient systems. By considering thermal expansion in engineering, manufacturing, and daily life, we can prevent problems and make the most of the materials at our disposal. Remember, the next time you see a bridge joint or a stuck door, thermal expansion is at work.